This video is on integration by parts, which is usually learned around the second half of your calculus class and can be kind of confusing. So first of all, here's a formula that you learn out of your textbook for integration by parts. I first want to show you where that comes from so it's not so obscure. It's really just the integral form of the product rule. So I'm assuming you've seen the product rule by now, which says that the derivative of two functions, u and v, we'll call u of x, v of x, which are just two random functions. So that's the product of two functions, is equal to the derivative of the first function, I'll just use prime for now for derivative because it's easier, times the second function just as is, plus the derivative of the, plus the first function, u, just left alone, times the derivative of the second function, v, like that. So I'm assuming you've all seen the product rule. So to get the integration by parts formula, we're simply going to take the integral of both sides of the equation. Like that. Now on the left-hand side here, you can see that we just have the integral of the derivative. Those are inverse operations, so they just undo each other, and we're just left with u and v. Integral of the derivative. Equals. On the right-hand side, we can integrate both functions individually. U prime, expanding that integral. Like so. Okay, and then we're simply just going to isolate this term here. So I'll subtract this guy from both sides. I'll just go straight to the result. So we get the integral of u of x, v prime of x, dx equals u of x, v of x, minus the integral of u prime of x, v of x, dx. And that's pretty much it. If we put it in differential form, I'll just simply use the fact that if we, let's see, dv dx equals v prime of x by definition, right? And then if we just move the dx over, we get dv. Okay, so I'm going to see how this appears here and here. I'm going to substitute that out, and then we are done, basically. So we get, writing a little more simply, u dv equals uv minus the integral of v du. There it is. Yay. So it's not as complicated as it looks. Now I just want to do a real quick example so you can see how it works. So let's say we want to take the integral of x e to the x dx. So that's basically the product of two functions, right? So whenever you use the integration by parts, you want to assign, we're basically matching it up with this part here. So we need to call one of the functions u and one of the functions dv. Now it's not always clear which one's which. Sometimes you just have to experiment. We'll try calling this one u and this one dv. The dv one has to have the differential in it. Okay, so let's just see what happens. So if we call u is x, dv is e to the x dx, then we want to find du. In this case, is simply dx. And then we want to find v, which is the antiderivative of e to the x dx, which is simply e to the x. Okay? And this should work. Now we just run it through the integration by parts formula, which says the integral of x e to the x dx equals uv, which in this case is x e to the x, minus the integral of v e to the x du. Okay, and we get a new integral, which we can totally do. Again, we see the integral of e to the x again, which is just itself, plus a constant. You'll know you picked the u and dv wrong if when you get to this step, and it's an integral that's like just as complicated as the one that you can't do basically. So had we could have tried having u be e to the x and dv be x dx, but when we got to this step, we would see that it's an integral that's not easy. So then you can just try it the other way. Okay, so we're basically there. So equals, we can just factor out an e to the x. And there you go, that's it. I hope you find this helpful. Always feel free to reach out to me if you need any help explaining. All right, have a good day. Take care.